Here we have a pipe which is predominantly made of material of refractive index 1.68. So this whole thing is material of refractive index 1.68. Rays are entering from outside, say air or vacuum. Then there is first refraction taking place here in this interface, and then we have an outer covering of material of refractive index 1.44. So this is that outer covering. So one more refraction will take place here. So that's second interface. And then we have to discuss total internal reflection. For total internal reflection, this angle I dash should be more than the critical angle. Let us apply the law of refraction, that is Snell's law, for this interface. So we have mu of the air, which is 1, into sin I, equal to mu of the material, which is 1.68, into this sin R. But then this I dash and this R, they are related. I dash is 90 minus R. So sin R would be cos I dash. Let's now apply Snell's law for this interface. So now we have 1.68 times sin I dash equal to 1.44 times sin 90. Here I dash is the critical angle, and therefore this is 90. I dash is critical angle, that means it is a minimum value. Beyond critical angle, we know that total internal reflection takes place. And if I dash is critical angle, that is a minimum value, then cos will be maximum. If angle is minimum, cos is maximum. And therefore, sin I will be maximum because sin I is linearly related to cos I dash. And if sin I is maximum, then I is maximum. So when I dash is minimum or when I dash is critical angle, then I will be maximum. Now we have these two equations. We can square and add them, and we would have 1.68 square equal to 1.44 square plus sin I the whole square. From this we can find angle I. Angle I comes to be around 60 degree, slightly less than that. And since this is the maximum value of I would lie between 0 to 60 degree. Now practically we can't have I 0 degree. So it is the dimensions of pipe that will put restriction on the minimum value of I. So theoretically 0 to 60, practically whatever minimum value is possible looking at the dimensions of the pipe to 60 degree.